In today's lesson, we're bringing together a lot of the different things that we've been doing. So we've been using flowcharts, we've been isolating the unknown algebraic expression. Now we're going to bring all that together and solve the algebraic expression and then find out what it is via backtracking. And that will make more sense once I show some examples. So here are the first questions in your work today. So you might notice instead of just having one set of flowchart boxes, we have two. And what we're going to do is we're going to go forward and then go back to find out what the unknown is. So what does that mean? So let's take the first one here. It's a worded problem. It says multiply 2, add 7, and the answer is 11. So we still need our unknowns. We'll make that x. Okay, if it's given in the question, that's great. But if it's not given, just make up your own letter. So x, the first step is multiply by 2, and that becomes 2x. And then we add 7, so plus 7, so that's 2x plus 7. Now, the answer is 11, and we put the answer down below, okay, because that normally we would write equals 11, wouldn't we? But for our flow chart, we're going to put that below because now we're going to work backwards and we're going to figure out what the x is. So if I'm adding 7 here, I'm taking away 7 there, which will give me 4. And if I'm multiplying by 2, well, down here I'm dividing by 2, which would give me 2. Okay, so as you can see, we're going forward to solve the algebraic expression, or to get the expression, I guess. Sorry, this is the algebraic expression x, and this is the algorithm. And then we're backtracking to figure out what that algebraic expression is. I just started, anyway, to figure out what x is. So x equals 2, okay? And this is a flow chart to show you what's happening. Now, I really recommend doing your working out on paper today because in doing this, working out on the slides would be really difficult. I could draw out this little table for you, but then having these above values would just be really messy. So if you can do it on paper and then just insert the pictures. Okay, so what does that look like here? So we're given the x, so put the x in the box here. Okay, and we're not so much, it's not spelled out for us, but all the information that we need is here. So I know that the answer is 22, so I can just put that in there to begin with. So the first step is 5x. So to get 5x, we need to multiply this by 5. Okay, so 5x. And then plus 7 is separated from the x, so I know that's just plus 7 like that. So 5x plus 7. So can you see how we're building? We're breaking it down, building it up. Now we're going to go backwards. So 22. Here we were adding 7. Here we're taking away 7. So 22 take away 7 is 15. Here I was multiplying by 5. Down here I'm dividing by 5 because of our inverse operations. And the answer is 3. So x equals 3. For all of these, you can test them. And the quickest way to do that is just slot in. So 5 times 3 is 15. 15 plus 7 does equal 22. Let's test this one. X is 2, so 2 times 2 is 4. 4 plus 7 is 11. Okay, so we're breaking down, okay, all the different things that we've been doing, going forward in the flowchart, going backwards in the flowchart, and finding out what our algebraic expression is. Now, this might get a bit tricky here because remember our rule, when we add first and multiply second, okay, we have to multiply into both expressions, the x and the 7. So what does that look like? Well, we have x. Now you might be tempted to multiply first, but remember that's second. So x and 7 are together. So the first one is that, x plus 7, and then we multiply, so times 3, which is what gives us that in brackets, and it equals 24. So we put 24 down there. Now we have to go backwards, so divide by 3. So 24 divided by 3, excuse me, is 8. Up here we're adding 7. So down here we're taking away 7, and it equals 1. So let's test that. 3 times 1 is 3. 3 times 7 is 21. 3 plus 21 equals 24. Great, so we've done that there. Okay, so we're going through this process because this is a great strategy, okay, when we're trying to figure out what our expression is. And we're breaking it down so you can see all the parts that go into this, because this looks very busy and very intimidating at times, or questions like this. So for us to break it down this way, it allows you to see what's going on. Question 4 that you're going to be doing in your work looks a bit like this. Again, when we have these fractions, it can be a little bit intimidating. I'm going to have to squish it in. We'll see how we go. Like that. Okay, so our value is x, okay, and it's over 3. Okay, it's not all over 3, so division is what we did first. Divide by 3, so that gives us x over 3. Sorry, it's a bit squishy there, but you get the idea. Then we plus 5, so x over 3 plus 5 equals 6. So let's go backwards. Sorry about all the squishiness. So we'll adding 5, so we're going to take away 5 there, which 6 take away 5 is 1. We're dividing by 3 up here, so therefore we multiply. 1 times 3 is 3. Okay, so x equals 3. So let's input that. If that was 3 there and that's 3 there, so 3 over 3 equals 1. 1 plus 5 is 6, so that's correct. Okay, and the last question that you'll be doing today, let's get a new page real quick, is essentially the similar question, but it's all over 3. Okay, this is similar to what we did last lesson, so you have to remember the order in which you do things. Can you see how each lesson we've built upon the previous skill? Okay, so here, because it's all over 3, that means we added the 4 before we divided. So we start off with our x plus 4, like that. So it was x plus 4. Then we're dividing by 3, and because we're dividing by 3, this all has to be divided by 3. Not just the 4, not just the x. So it then looks like this. Okay. And that equals 6. So can you see, we're given the question here, but we're breaking it down for you to see all the different parts. The reason we do that is because then we can identify the inverse operation to figure out what x is. So 6, if we're dividing up there, we multiply down here. Is 6 times 3, sorry, equals 18. If I'm adding 4 up here, then I'm taking away 4 down here, which equals 14. So let's input that. So it would be 14 plus 4 divided by 3 equals 6. So 14 plus 4 equals 18 over 3 equals 6. 3, 6, 9, 12, 15, 18. Yes, that does equal 6, correct. So that's what we're doing today. We are using our forwards flowchart and then backtracking, which is essentially our inverse operations to get that. Okay, this is really breaking it down for you to see how to do the question. It would be great if I could see this working out in your work rather than just the answer, because when we do this working out like this, it's really easy to pick up mistakes, because the shorthand version of this, the next step is essentially this. You're given this question here, x plus 4 equals 3, and we kind of touched on this in another lesson. The next step here is we want to isolate the x by itself. So essentially, I want to take this 3, which I'm dividing and multiply over here. So it would be x plus 4 equals 6 times 3. I'll then move the 4 over here, and as I'm doing that, I'll do this multiplication, which would be 6 times 3 is 18. And then because I'm adding 4 here, I'm going to take away 4 here. So therefore, x equals 14. Okay, so we do get the same answer. But can you see, by doing it this way, we're really breaking down the maths that we're doing and understanding all the different moving parts. Okay, this is another way of working it out, but it'd be a lot harder to explain what you're doing. This way, with the forwards flowchart and the backwards flowchart, you're able to identify any mistakes that you do, and you're able to explain it. So today, we're just working on this strategy of solving a problem. As you all know, there's always different strategies that you can use to solve the same problem, but this is what we're working on today.